Hi everyone, welcome to Study with Akshay, and this is Akshay. In this particular video, we are going to start with example numerical set 1. So before getting started, if you have not subscribed to my channel, please do subscribe and hit on the bell icon to get regular notifications. Let's get started. Again, here also questions will be displayed on the total screen. So we have the first question. Prove the identity tan A plus cos A equals secant A into cosecant A. Okay, with the question, let's start solving. So either we have to start with the LHS side and get the RHS, or start with the RHS and get the LHS. So it's better. For a tip, you can take a complicated side and you can start solving it. So complicated side I feel over here as LHS. So in our LHS, there is tan A plus cos A. Tan A plus cos A. So this tan and cos can be expressed in terms of sin and cos. Using our quotient relations, we can express them. So sin A by cos A plus cos A by sin A. I will be using two different colors over here. This is one color and this is other color. Okay, whichever I write in this yellow color is known as just for your reference. So we will not be using it in our examination. So let's start with this. Let's take the LCM. Sin square A plus cos square A divided by cos A sin A. Right. So here, whatever I write here is for your reference. We know that sin square A plus cos square A equals 1. This is our first identity, right? Sin square A plus cos square A equals 1. Okay. With this knowledge, let's substitute 1 divided by cos A sin A. 1 by cos A is nothing but secant A. 1 by sin A is nothing but cosecant A. And hence, we have got the result what was expected. People who were unable to copy, I will be displaying the solution as well now. You can see the solution which is displayed over there, and I have given some explanation also. Extra explanation is given over there why it is secant and why it is cosecant also. If the concept of this question are clear, we can move ahead further with the next question. Question number 2 has 3 subdivisions. First subdivision, we will take it as. Let me write down the LHS side because I start with LHS side. Cos to the power of 4a minus sin to the power of 4a. This is our LHS. Okay. Hope you have made a note of the question. The first sub question I'm going to start with. So this can be written as cos square A d whole square minus sin square A d whole square. So we are all aware of the algebraic identities A square minus B square. So here it is nothing but cos square A plus sin square A into cos square A minus sin square. So we also know that cos square A plus sin square A equals 1. I'll write it over here. Equals 1. Okay, this is just an extra information for you to understand that. So 1 into cos square A minus sin square A. and the result expected in the RHS is in the form of cost. Let's convert all the sign in terms of cost. So sin square A equals 1 minus cos square A. Minus sin square A will be minus 1 plus cos square A. Substitute that over here. Cos square A minus 1 plus cos square A. 1, or I will write it as 2 cos square A minus 1, which is expected as our RHS. Okay. Hope this part is clear. You can see the solution for it. Let's move ahead with the next question. Next question states that in the LHS, 1 plus cot AD whole square plus 1 minus cot AD whole square equals 2 cosecant square A. So let's remove the brackets from the LHS. I will start from the LHS only. Okay. Start from the LHS only. 1 plus cos square A plus 2 cot A, then plus 1 plus cos square A minus 2 cot A. Plus 2 cot A minus 2 cot A gets cancelled, and then we will add up these two. We will be getting 2 plus 2 cos square A. 2 we will take it as common, 1 plus cos square A. We know that 1 plus cos square A equals cosecant square A. Cosecant square A. So using that, 2 cosecant square A, which is required in our RHS. Hope all are getting a clear picture of how to solve the problem. Let's start with the next question. That is the third question. It states that tan to the power of 4a plus tan square a equals secant to the power of 4a minus secant square a. Okay. How to solve this? Let me start now. So here, tan square a is common from the LHS. Tan square a is common. Then we will be left with tan square a plus 1. Right, in the LHS. Then we know tan square a plus 1 equals secant square a. Right, tan square a plus 1 equals secant square a. So with that knowledge, tan square a can also be written as, I will write again over here, tan square a can also be written as secant square a minus 1. This will be applicable for this and this will be applicable for this. Let's apply them. Secant square a minus 1 into secant square a. Secant to the power of 4a minus secant square a, which is required in our RHS. It is so simple and it's so easier for it to solve as well. Check the solution. With this, we can move ahead with question number 3. Question number 3 basically has 4 sub-questions. The first sub-question is sin A divided by 1 plus cos A plus 1 plus cos A divided by sin A equals 2 cosecant A. So let me get started with that. Sin A divided by 1 plus cos A. 1 plus cos A plus 1 plus cos A divided by sin A. This is given in our LHS. Let's take the LCM. Sin square A plus 1 plus cos A the whole square divided by 1 plus cos A into sin A. Okay, if people who are making running notes along with me, you can pause the videos and make the running notes, because this problem is quite a bit. I will be erasing from the top as and when I am done. And then at the end, I will be displaying the result on the other window. No need to worry. So, sin square A plus 1 plus cos square A plus 2 cos A divided by 1 plus cos A into sin A. We know that sin square A plus cos square A equals 1. So here there is sin square A and here there is cos square A. We will substitute at those places 1. I'll be erasing from the top as I have told. So 1 plus 1 plus 2 cos A divided by 1 plus cos A into sin A. Then 1 plus 1 is 2. 2 is common in both. 2 times 1 plus cos A divided by 1 plus cos A into sin A. So your 1 plus cos A is there both in numerator and denominator. So they both get cancelled as shown. Then we will be left over with 2 divided by sin A. We know that 1 by sin A is cosecant A. So 2 divided by sin A is 2 cosecant A. 2 cosecant A, which is equal to our RHS. So the solution for this question is displayed in the other window. Oh, the solution is visible. Moving ahead with question number 3. Second sub-question under question number 3. So it states that 1 plus cos A divided by 1 minus cos A equals cosecant A plus cot A the whole square. So for this question, I am preferably solving it by using the RHS. Okay, I will show how to solve it by using RHS. They are given it as cosecant. Cosecant can be written as 1 by sin A. Cot can be written as cos A by sin A. These are our quotient relations and reciprocal relations. I'm making use of them to solve the problems over here. The whole square, which is equal to 1 plus cos A the whole square divided by sin square A. I am taking square over here only. Since there is common LCM, sin A only it will become. Instead of putting square completely, I am individually squaring them. So we know that sin square A equals 1 minus cos square A. 1 minus cos square A. With this knowledge, let's substitute sin square as 1 minus cos square A. 1 plus cos A B whole square divided by 1 minus cos square A, which implies this is 1 plus cos A into 1 plus cos A. Here A minus B, A square minus B square, we can write it as A plus B into A minus B. These two get cancelled. Then we will be left over with 1 plus cos A, 1 minus cos A, which is equal to our LH. Let me display the solution. Moving ahead further with the third question of the main question 3. So it is given as cot A plus tan B divided by cot B plus tan A equals cot A tan B. Let's solve this. So I will be just taking off LHS only. So cot A can be written as cos A by sin A, and then tan B can be written as sin B by cos B. Similar way, denominator, this using LHS only I am solving. Denominator can be written as cos B by sin B plus sin A by cos A. Let's take LCM and simplify them. Cos A cos B plus sin A sin B divided by sin A cos B, all divided by cos A cos B plus sin A sin B divided by sin B cos A. So assuming this complete thing as one term and this complete thing as one term, we will be cancelling completely like this. Then yeah, there is no use of identities. You can make sure that where the identities are used. And while choosing in the examination, I prefer if you choose such kind of questions, it would be helpful for you for scoring also. So we will be left with this comes to the numerator by taking the reciprocal sin B cos A divided by sin A cos. Next, let's group them. Cos A by sin A has one term into sin B by cos B as the other term. Cos A by sin A is nothing but cot A into tan B, which is nothing but equal to our RHS. Right. So let me display the solution window again. The same thing, whatever I have written on the board is displayed. Moving ahead with the fourth sub question under the main question C, prove that cos A divided by 1 minus sin A equals 1 plus cosecant A. So obviously I will be taking LHS only because LHS is more complicated. Starting with the LHS, Starting with the LHS, cos A, cos A, cos A, cos A, cos A divided by 1 minus sin A, which implies cos A into cos A by sin A divided by 1 minus sin A. Cos A into cos A is nothing but cos square A divided by sin A into 1 minus sin A. So here cos square A can be written as 1 minus sin square A, 1 minus sin square A, which implies 1 minus sin square A divided by 1 minus sin A into sin A. So it is in the form of A square minus B square. So 1 plus sin A into 1 minus sin A divided by 1 minus sin A into sin A. 1 minus sin A and 1 minus sin A gets cancelled. Later on, we will be left with 1 plus sin A divided by sin A. So this 1 plus sin A can divided by sin A can be written as 1 by sin A plus sin A by sin A, sin A by sin A. This becomes 1. So 1 by sin A is cosecant A plus 1. So which is expected in our RHS. Okay, let me just display the answer key. Okay, next moving ahead with the next question. That is, prove that secant A minus tan A divided by cosecant A plus cot A equals cosecant A minus cot A divided by secant A plus tan A. So here, this kind of question can be proved in a different way. So here we have to write few standard results. WKC refers to we know that secant square A minus tan square A, secant square A minus tan square A equals 1. And then we know that cosecant square A minus cos square A is also equal to 1. Since their RHS are equal, we can equate both the LHS as per our rules of linear equations. Secant square A minus tan square A equals cosecant square A minus cos square A. So this is in the form of A square minus B square. So henceforth, secant A plus tan A, secant A minus tan A equals cosecant A plus cot A, cosecant A minus cot A. Okay, so here a bit arranging of the terms, we will be getting up the result. So we will keep this term over here and shift this one to the other side. Similarly, We will keep this term over here and shift this one to other side. Okay, let me write the given expression. Secant A minus tan A, denominator this part is coming, cosecant A plus cot A equals, here for this, cosecant A minus cot A divided by secant A plus tan A, which is our required result, and hence this is proved. Okay, if you want, you can see the solution which is displayed on the other window. There also the same method is followed by just taking this as equation 1 and 2 and then equating both of them. With this knowledge, let's move ahead with the next question. In the fifth main of proof that, we have two different sub-questions. First question states root of 1 minus sine A divided by 1 plus sine A equals secant A minus tan A. So let me take the LHS because it seems to be complicated and then solve for RHS. LHS, taking the LHS, we have root of 1 minus sine A divided by 1 plus sine A. Then here in this step, what I will be doing, I will write it over here and then only I will solve. Multiply and divide by root of 1 minus sine A into root of 1 minus sine A divided by root of 1 minus sine A. Here on the numerator, it is 1 minus sine A d whole square, 1 minus sine A d whole square, d whole root, divided by 1 minus sine square A root. So this root and this root gets cancelled, and in the next step, 1 minus sine square A, 1 minus sine square A can also be written as cos square A, right? So the next step, I will be writing 1 minus sine A divided by cos square A the whole root. So here also square and square root gets cancelled. So we will be left over with 1 minus sine A divided by cos A. So this, at all splitting, we get it as 1 by cos A minus sine A by cos A. 1 by cos A minus sine A by cos A, which also states that 1 by cos A is nothing but secant A minus sin A by cos A is nothing but tan A, which is our required result at our RHS. You can see the first sub-question solution being displayed. With reference to this question, we are done with it. Moving ahead with the second sub-question under the main question 5, we have tan A plus secant A minus 1 divided by tan A minus secant A plus 1. So in this case, we will be taking the LHS part and solving over here also. So before I go ahead with LHS part, let me just write one thing and then start. We know that secant square A minus tan square A equals 1. Then tan A plus secant A minus secant square A minus tan square A. Because here in this part they have given it as 1. Let's only put either for the numerator or for the denominator 1, not for both. Okay. Then divided by whatever was given, tan A minus secant A divided plus 1. Tan A minus secant A plus 1 was given in the denominator. So here I will take tan A plus secant A as one group, minus I will keep it as such. Here it's in the form of A square minus B square. So A square minus B square can be written as secant A plus tan A into secant A minus tan A divided by tan A minus secant A plus tan A plus secant A 1 minus secant A, because 1 minus secant A plus tan A all divided by tan A plus minus secant A plus 1. So if you keenly observe the question, this term is same as this term, only the terms or the elements have been rearranged. So these two can mutually get cancelled. So we will end up in getting tan A plus secant A. Tan A plus secant A. So when expressing these in the form of sin and cos, sin A by cos A plus 1 by cos A equals sin A plus 1 divided by cos A. So which is our required result at RHS. You can see that displayed. Yeah, it's time to end this video. If you have liked this video, please click on the thumbs up button. Please share this video. Thank you. Stay home, stay safe. In the next video, we'll be continuing with the example numericals from 6. Thank you.